Please welcome David Lord.
Hello, my name is David Lord. I'm the lead maintainer of Flask and the Palettes projects. You can find me pretty much anywhere at Davidism. I have a full-time job as a software engineer, then devote plenty of my free time to programming and participating in the Python community. I also enjoy hiking, brewing beer, and I'm learning Japanese. Today I'm talking about GraphQL, a library called Magical that I wrote, and my experience developing GraphQL APIs. This is a cat. Right as my talk was accepted, this article titled, Why After 6 Years I'm Over GraphQL was published, and it said exactly what I was planning to say in this talk, and got a lot of agreement from other devs, so that's very validating, but I was a little worried for a second. But I definitely encourage you to go read this as well. So GraphQL is a specification for writing an API. I'm going to give a very abbreviated introduction to it here. There are a lot of complex features in GraphQL, but they don't meaningfully affect what I'm going to talk about today. You can check out the spec and an overview for yourself if you want to see more. A GraphQL API defines a graph, surprise, surprise, where each node represents one selectable thing, and the edges are functions that describe how to get from one node to the next. The graph is called the schema. Nodes are referred to as fields and have a type. Edges are referred to as resolvers, and because they are functions, they can take arguments. Each field has a type. A type can be a scalar, like a string or an integer, or an object, which is a collection of more fields with more types. A type can be marked as not null, or as a list of values of that type. Arguments to field resolvers are also typed, and can either be scalars or objects with more arguments. Here's what a simple API for authors and books looks like. Each author has a name and a list of books they've written and a list of books that are their favorite. Each book has a title and an author. The author name field is a scalar string type. The books field is an object type referring to the book type, which itself has fields. There are two query fields to get an author by name or a book by title. To make an API call, the client builds a query, which describes a traversal of the graph. Starting at the root, which is called query, you select a field with arguments. If the field is an object, you select more nested fields until every path ends at a scalar. What's cool about this is you can, by describing the query, you also describe the size and shape of the data you'll get back. So in a traditional API, you might return an author and maybe include the IDs of the books they like, so you can subsequently request information about those. But with GraphQL, you can ask for the author, their liked books, the authors of those books, and the books they authored, and do some nice data analysis with one query. You might already see the problem with this, though. It's possible for users to construct arbitrarily complex queries and send them to your API, probably well beyond what you intended to support. So even that was a very, very basic overview of GraphQL. But even that was pretty complicated, and I elided most of the stuff. Let's move on to the library I wrote, Magical, which stands for Mostly Automated GraphQL, and is pronounced magical, not MagQL. We originally started looking at GraphQL for work around 2018. Many of our projects involved converting Excel files into databases and web applications with actual security, multiple users, data validation, not an Excel file. We were often designing the same basic list, detail, create, update, delete APIs per model. GraphQL had the appeal of matching how we thought about the data on the back end and being able to select exactly the data we needed and introspect the schema to do stuff on the front end. We decided to write Magical to automatically turn our SQL Alchemy data models into a GraphQL API. So before I decided to write an entire library, I did find some other libraries for GraphQL in Python. Graphene, Ariadne, and Strawberry. GraphQL and all those libraries were much younger in 2018, and none of them ended up feeling right to me for one reason or another. I know there's been plenty of development on them since, but they weren't really helping me understand the complexity of GraphQL. But with hindsight, today I'd say that they were all doing a good job even back then, and the problem is just that GraphQL is so complex. As far as I'm aware, all Python GraphQL libraries are wrappers around GraphQL core, which is a direct port of the reference implementation in JavaScript. Core implements all the various objects needed to build a schema, a parser, a parser to turn query documents into an AST, and an execution engine to traverse the schema based on the parsed query, run each resolver, and build the result or return errors. So it does quite a lot, but it's pretty difficult to work with. It's pretty low level. Its schema objects are immutable, so generating something then customizing it later is not possible. It does have forward references, but only as Lambda functions, which is pretty verbose to write and means you can run into circular import issues. GraphQL itself, like the spec, does not define how to do input validation or report validation errors. It just says, send arguments, input arguments to the API, and we'll parse them and use them. It doesn't say anything about, so the GraphQL API itself will do some basic validation about the query syntax, the types, and the required inputs. But we needed to be able to validate user input with complex rules and then identify which inputs in the UI to put error messages next to. And the spec just didn't define any of that. So Magical is designed to address these issues. The schema is mutable. It can be defined and then modified before finalizing. Types can be referenced by name. Robust input validation can be applied anywhere in arbitrary input structures, and errors in the result can be matched back to those arbitrary locations. We're unique with that last feature. No other library provides input validation, probably because it's not in the spec. But pretty much every other library just says, if you want to return errors, make that part of your API and do it yourself. In order to provide a mutable schema, Magical reimplements every core class that GraphQL core implements. So schema, object, field, interface, union, argument, input object, input field, enum, scalar, all the built-in scalar types. These all provide, so Magical's versions of these all provide a nicer interface to access and modify all of the attributes describing these objects, such as using plain dicts to map fields and arguments, using decorators to register validators and resolvers, adding shortcuts to be able to refer to types by strings or by their imported objects, and to use string syntax to specify that looks like GraphQL syntax to specify whether fields are non-null, are lists, etc. So yeah, forward references are also handled at this mutable stage. In GraphQL, every type has a unique name, and Magical takes advantage of this. So once the entire schema is defined, it goes through a finalization step. Magical traverses the schema that you've defined, collects all the nodes, the names, and the types, verifies that every node with a string reference has a corresponding named type object that it's found in the graph elsewhere. Then it loops over all the nodes it's collected and replaces any nodes with names. It replaces the names of types in any nodes with the type objects themselves. Then it does a second traversal pass to produce a corresponding immutable GraphQL core schema, which will be used when executing the queries. So we start with our mutable Magical schema, do a bunch of traversals of the graph to collect names and turn them into types, and then finally produce an immutable GraphQL core schema, which can be executed. And finally, input validation. This was extremely tricky to design and implement because inputs can be arbitrarily complex. At the most basic, a field resolver will have arguments with scalar types, like a Python function itself. But an argument can be an object with nested arguments. An argument can be a list, or a list of lists, or a list of objects with arguments that are lists of other objects, etc. You might want to validate an individual argument, or all the arguments collectively. If you're validating a list, and are you validating it as a single value of all its items, or are you validating each item individually? So in Magical, you can attach validators to individual arguments and input fields. You can also attach validators to entire fields and input objects to validate all their arguments at once. And you can wrap validators in list syntax to indicate they should validate each item in a list. All the validators that you define anywhere in your graph or anywhere in your inputs for a given field are collected and run before the resolver for that field. So you get to define your resolver that just does what you want, and you get to define your validators, and then Magical combines the validators in your resolver into one big GraphQL resolver that does the right thing. So if any validation errors occur, it won't cause the resolver to run, and instead all the errors are collected into a structure of nested dicts and lists that matches the layout of the input in order to let the UI know where to put each of those messages next to the UI inputs. As I said, this was really complex to figure out. There was no spec for it. I just had to kind of like look at what is all this complexity, what are the different possible ways we could be using this API, how can we validate it? I probably shouldn't have done all of that. Because we don't actually take advantage of any of this complexity in any of the applications we've written. But it was one of those puzzles that once I started thinking about it, I felt a great need to solve it completely. It was difficult, but it was fun, and it was satisfying to get it right. And I think I like that this feature makes my library unique compared to other GraphQL libraries. So all that is Magical Core. That makes it easy to define GraphQL APIs, but we wanted it to be even easier. We already write our database models, and our API looks very similar to our database models. So why not generate the schema from the models? So Magical SQL Alchemy does exactly this. It defines resolvers that can handle querying a model for a single row, a list of rows with sorting, filtering, pagination, create, update, and delete rows. It also provides global search to match a search term against every text field in every registered model. And we wanted to be able to warn users before deleting something by showing them what other objects in the database would be affected. Those last two, again, are unique to Magical. They're not something I've seen other libraries that generate APIs automatically generate. But they make it really easy for us to write some very user-friendly UIs and applications. So if you pass in the author and book models from SQL Alchemy, which are at the top there, to Magical SQL Alchemy, which is just those last 3 lines there, it'll generate this entire API for you. You don't need to be able to read this, but it's everything you need to be able to do to work with those objects. So you get out a book list, a book item, a book create, book update, book delete queries, plus the same for author, plus 2 global search and check delete queries, plus all the objects. Magical SQL Alchemy detects columns that have default values or that are nullable or not, and makes your create and update APIs work with those. It knows how to join across relationships efficiently, etc. So then we needed to wire up that API we've just created to HTTP requests and responses, and that's where Flask Magical comes in. It's a Flask extension that takes a schema, then adds endpoints for executing queries and introspecting the schema. To make a query, you make a post request to the GraphQL endpoint, passing in a JSON object with a query and variables, and you get back a JSON object with data or errors. Another thing the spec doesn't say anything about, the GraphQL spec, is file uploads, something that is quite common in web APIs. I still don't understand why they omitted it from the spec and why they haven't addressed it since. But you can't send data along with a JSON request. You could, but you'd have to base64 encode binary data and put it in your JSON string, which is really inefficient. But we've been uploading files well before GraphQL existed, with just regular multi-part form data from HTML forms. So there is a way to upload files to APIs. And so there is a de facto standard alongside the GraphQL spec that provides a way to encode a query, variables, and files into multi-part form data, and then turn that into the same sort of just plain JSON query behind the scenes for execution. But once again, inputs can be arbitrarily complex, and there could be a file argument anywhere in that arbitrarily complex input. So yes, we can put files into our multi-part data, but the spec and the code that supports it is really complicated because it needs to be able to look over all the variables, find any placeholders anywhere in the arbitrarily complex input, and replace them with the file data from the form data. But Flask Magical does all that for you. And this is all you need to publish a GraphQL API with Flask Magical. You create the extension, you pass it the schema you built, and you call a init app. So that's Magical in a nutshell. The goal of it is to write as little code as possible. We wrote our SQL Alchemy models, and then we wrote a couple lines to generate the entire API from those models, and we wrote literally 2 lines to expose that to Flask. So what I've built uses SQL Alchemy and Flask, but Magical is architected in a way that allows building additional integrations pretty easily. I'd love to see Django Magical, or magical data classes, or something entirely different. Here's what the author and book API would look like. I excluded the SQL Alchemy models, but this is the rest of the code that creates that author and book API we talked about with Magical, Magical SQL Alchemy, and Flask Magical. You set up the SQL Alchemy models, set up a magical schema, use Magical SQL Alchemy to generate an API from the models, add it to the schema, and use Flask Magical to expose the API. I will have URLs for this API and the next one in a few slides that you can play with. Here's something a lot weirder, though. GraphQL graphs can be self-referential. A type can refer to itself. So I thought, I could make a calculator that way. This entire API is a single self-referential object. Each field is an operator, which takes the parent value, performs the operation, and returns a new value, which has the same fields to do more operations. But the cool thing about GraphQL also is that you can select multiple fields on an object. So you can try out different operations and see the value change during a chain of operations. So I can start with the value 2024. I can add 2, then get that value back and multiply that value by 4.5. But then I can also kind of in parallel try modding it by 32 and then adding 100.2 and dividing that by 3. And you can get back answers all along the way. Is this useful? No. But it's cool, and it's something I think you can only do in GraphQL, and I think Magical makes it easy. I could also imagine, and I just didn't have time to build, a text adventure API, where every node is the player's position, and every field in that node is an action they can take there, right? And so you could try out different actions instead of save scumming. You can play around with both the APIs I just showed at these URLs. I'm sorry they're a little complex, but I'll be on this slide for a little bit more. That author and book API has nothing in it right now, but it doesn't require authentication either. So whoever figures out how to automate putting in all the books, we'll see how Fly.io handles that and what I pay for after this. I'm really proud of what I've designed. I encourage you to read through the docs, look at the code. It's well commented to explain how a lot of these tricky implementations that I've talked about. But after all this effort to learn the GraphQL spec, to implement all of its complexity and add additional complexity on top of it, after I've observed how we actually ended up using this and how our developers feel about GraphQL, we've come to the conclusion that we don't actually want to use GraphQL. In addition to everything I've mentioned already, here's the things we've run into. Not this cat. So in a traditional API, an endpoint directly maps to a view function, which validates all the input at once, queries all the data at once, decides what data to return based on permissions, etc. The theme here is all at once in one place. GraphQL, on the other hand, splits every field into a separate resolver function. And those queries can be arbitrarily complex. So you can have an arbitrary number of individual resolver functions running for any given query. A context object is passed around between every resolver during execution, so it's possible to store state and communicate between resolvers. But now you need to learn this entire other thing called the GraphQL data loader pattern to take advantage of this and make your data queries efficient. But queries can be arbitrarily nested, so even if you're smart about querying your database, it's very easy to shoot yourself in the foot and create a query that is incredibly inefficient. SQL Alchemy has this exact same problem on its own. If you have relationships between models, you select one model and then you access the relationship, that issues another SQL query to the database, unless you pre-join and preload relationship data. So Magical SQL Alchemy knows this, and it can rely on SQL Alchemy's session cache and its ability to build queries iteratively as we go through the resolvers. So it introspects the query AST before the execution actually starts and figures out, OK, I'm going to be querying this object, I'm going to be querying these fields under it, so I need to do these joins so that I only end up issuing one query, and it is efficient. So once again, Magical has saved you from a pitfall of GraphQL. But again, it's very easy if you're just writing your own resolvers or didn't know to do this to end up doing something that results in many, many database queries from one GraphQL query. It's working. I'm distracting them. Debugging is harder with GraphQL. Every request looks exactly the same in the server logs because there's a single GraphQL endpoint rather than an endpoint per function. You have to inspect the request body to see what the query even is because it's a JSON blob. If one resolver fails, other resolvers already executed and are no longer part of the frame stack. So it becomes harder to keep track of what's happened so far and what's going on in a query if you step into a debugger. That's why I just keep thinking about these cats instead. So an object, there's some complexity with the terminology in GraphQL as well. I went through that whole list of GraphQL core objects that Magical re-implements, but even in there, an object is the output type and it has fields. Fields have arguments, which are input object types, which is the input type. Input objects have input fields, which are arguments, but not the argument object that the fields have. And then scalars are input and output objects, types. This was hard enough to keep track of as I implemented it, and is a constant source of confusion every time I try to help another developer on my team understand this or debug it. You can omit arguments to distinguish between set this value to null versus don't update this value. So resolvers can have optional arguments, similar to Python quargs. Ideally, your resolver will take many named arguments like you would with a Python function. But in practice, you have to generate the query document as a string. And that query document is the thing that names the arguments you're going to be using. And then you pass the variables to that document. So it's a lot easier to have one argument named input that is a big typed JSON object, which makes your input validation more complex. Because it's much easier to build a JSON object that omits a field because you just leave it out or delete it, rather than omitting the name of an argument in the middle of a string you're trying to build. While any field resolver could take arguments anywhere in a nested query, this doesn't actually seem to be utilized in practice. So GraphQL has a lot of complexity in the spec, but I haven't observed people taking advantage of that complexity well, at least. It's not helped by the fact that queries and mutations are physically split up into two separate namespaces, as opposed to HTTP GET and POST, which are just basically arguments to API functions rather than actual separate namespaces for them. Because there's two namespaces, we can take things that should be logically grouped together, like book index or book item and book create, but book item is a query, book create is a mutation. So now they're in totally different places in the schema and in the documentation that's generated by the schema. Tutorials you'll find show arguments only for that only use top-level fields. The biggest public GraphQL API I'm aware of, GitHub, does not use arguments below the top level. So I think it's very telling that the very smart GitHub developers decided to go all in on GraphQL and still ended up creating a big flat namespace just like a traditional JSON API or OpenAPI spec. Something's going to go wrong here. So the theme is complexity. This affects our developer experience. Junior developers have a hard time learning SQL Alchemy, Flask, GraphQL, and Magical all up front, and then knowing what goes on where and why, and what the difference between it all is. Even developers who are experienced with GraphQL and Magical now still have trouble keeping track of it, including me. You have to decide, okay, am I going to implement something on the SQL Alchemy model or in the GraphQL resolvers? And does this make sense as a Flask endpoint separate from GraphQL, or does it go in the GraphQL resolver? What's the difference between resolvers and endpoints again? These are all questions that come up from my junior devs all the time. It makes authentication, caching, database querying, debugging, and testing harder. And this is only with the subset of GraphQL that I've talked about. There's even more complexity that I haven't had time to talk about, some of which Magical does implement as well. None of these problems are insurmountable, but they're not what we want to spend time on. What we've discovered instead is that we just want traditional form input with JSON output as an API. Generated from SQL Alchemy models still, but OpenAPI provides us the same tools to document the endpoints with their inputs and output types. The one thing we're missing is defining the shape of our data. But it's already normal to pass somewhat complex query string arguments for sorting, filtering, pagination. I don't think it would be unreasonable to implement a shape argument as well. We'd end up something that's less complex and closer to the web framework itself, which will be a lot easier for our developers to work with, and give us the features we were initially interested in. Magical isn't going anywhere. And of course, there are good ways to use GraphQL as well. Well, we're just one data point. I encourage you to try it out, but also to think about whether GraphQL is magical in the way that you need. Thank you.